Well, today we get to start a new chapter, but chapter 10 has still chapter 9 in it, okay? So 9 hasn't gone away. 9's going to be in chapter 10, and it's going to be also in chapter 11. So some of the reducing stuff that we do with it, the radical stuff, is still part of chapter 10. So the first section of chapter 10 has two pieces to it. The first one is just looking at going back and doing some factoring, solving quadratic equations that way. The second one is using a method called completing the square that lets us also solve quadratic equations with a method that we can use for that. So in getting into this, of course, our objectives, the first ones, solve the quadratic equation by factoring, or solve the quadratic equation using the definition of square root. And what that means, we've did this before. The definition of square root is you take the square root of both sides, and what it does is removes the square on one side and leaves you with the square root on the opposite side. So we've did this before. It's not something new. The second one is solving quadratic equations by completing the square. So that's the other one, and we're going to write equations with given roots. So those are the pieces that we're going to take a look at and see what happens. This piece, writing equations with given roots, we don't do that part, but it's still in this section. So continuing. The zero property, factor property, it says if the product of two or more factors is zero, then at least one of the factors must be zero. That is that A and B are real numbers, so therefore A could be zero or B could be zero if we multiply them together. And we already know that because this is just a fundamental rule with multiplication with zero. If you multiply something by zero, you get zero. So that's still that same piece that's in there. So what are quadratic equations? We've dealt with them back in chapter 6 when we factored things, and when we looked at those, we had equations that were written in this form of ax squared plus bx plus c, where a, b, and c are real numbers and a cannot equal 0. So we cannot have a 0 out in the front of here because what that would do is it would no longer be a quadratic equation, it would be a linear equation. And so if a were 0, it's no longer quadratic. So what do quadratics look like? Well, if you were to graph a quadratic on your calculator, it would come out looking like a U, or what's called a parabola. And as we proceed through chapter 10, we're going to do more with these parabolas. The information that we're finding today is we're going to find out where that parabola crosses our x-axis at. So we're looking at the spots. That's what we're going to force everything to do. It's going to show me where those two locations are at. Now, parabolas can cross in two spots. They can come down and only touch in one spot, or it can be a parabola that never touches x. And when it never touches x, of course, we have no solution for x's and what they come out to be. Or we end up with imaginary values. And imaginary, remember, those are the things that are underneath the radical that do not solve, and we do not come up with what they're going to end up equaling. And so that's what happens with this piece. So then, if we continue on, we're going to solve these by factoring. So factoring we've been doing for an awfully long time. And of course, that's add or subtract terms as necessary so that 0 is on one side of the equation, and the equation's standard form is where a, b, and c are real numbers and a does not equal 0. Then you're going to factor it completely, and we've been doing this, nothing new. So it's just taking your skills that you've had from before and putting them to work. So if there are fractional coefficients, multiply each term by the least common denominator so that coefficients will be integers, meaning no fractions. Where are we going to work with? So we can do that. And we've been doing that also by clearing out fractions. We did that in chapter 7. We did that in chapter 8. And so that's, again, not anything new. So it's taking that skill base that we've already built, and we're going to take it and we're going to go a little bit farther. So then step 3 is set each non-constant factor equal to 0. And solve each linear equation for the unknown. So we're going to solve it and find out what x equals, and then we're going to check each solution one at a time in the original equation. We found back in chapter 9 when we checked some of those, they didn't work. Remember that? This case, most likely they're both going to work. There's not really a time that they probably will not unless you did something mathematically incorrect with what you're working with. So that's what's going to happen. So let's take a look at one. So if this were my first one, is it set equal to 0? So you need to get it in that standard form of ax squared plus bx plus c is equal to 0. So we always want to have a 0 connected in there when we do these. So it's not. So I need to add 50 to both sides. So I end up with x squared minus 15x plus 50 equals 0. So now I have it where I could take a look at this and factor it. So what would it factor to? Again, skills from chapter 6, and we did a whole lot of factoring in chapter 7, so it's kind of a good time to review it as we get closer to final exam time. So what does this factor to? So we get x's. What's factors of 50 that end up being a negative 15? Yep, negative 5 and a negative 10. So then take each of these pieces and set them equal to 0. So I'm going to add 5. So I find x is equal to 5. Over here I'm going to add 10. And I'm going to find that x is equal to 10. So what are these two pieces showing me? So what they're showing me is if I had a parabola and I was going to graph that parabola, one x-intercept would be at 5. The other x-intercept would be at 10. So this parabola is coming through here, going down, and shooting back up. So what we found is where those 2 points cross. Okay, so we found x-intercepts. So later on, when we have parabolas and we're going to work with those, we can end up finding out where those x-intercepts happen to be. Okay, and so you think we're good with this piece? So plug it back in. 5 squared is 25. 10 and 5 times 15 is 75. So 10 squared is 100. 100 minus 75, or 5 squared is 25. Minus 75, so 25 minus 75 is going to give me a negative 50, so we're good. Plug in 10, 10 squared minus 15 times 10 is going to give me 150, so 100 minus 150 is also a negative 50. So we know both of our answers are good answers, and so we can use each one of them. Okay, so always look for this. Always look to see if you can factor it, because it saves you some time with what you have going on with these. So make sure you look and see if it's factorable. So about this one. This one I'm going to add 48 to both sides. So I'll let you get caught up on writing that on in your notes. So I get 3x squared minus 24x plus 48 is equal to 0. And before you hop in, and again, the review of reviewing factoring is I can pull a 3 out of all of this before I start factoring it. So if I can pull a 3 out, let's do that. So I pull a 3 out, I get x squared. 3 goes into 24, 8x times. 3 goes into 48, 16 times. And so now I have 3, and then I can factor the other part. So again, it's been a little while since we factored, so pulling back those skills is what we need to do. But I've got a positive 16 on the end, and I need a negative 8 in the center. So what's it going to give me for factors? 4. It's going to be a minus 4 and a minus 4. And so the 3, I don't need to do anything with. All it was is that it increased the size by 3. So both of these match each other. So x minus 4 equals 0. So if I add 4 to both sides, I find out that x equals 4. So my parabola in this case is only touching at 4. So it's going up and doing one of these things. So it's not even in there. It's not even touching 2 spaces on the x-axis. It's only touching in 1. So it has 1 specific location. And when we get into the quadratic equation, we'll talk about that too, of what pieces, what tells us that we have 1 answer, or tells us we have 2 answers, or tells us we have more answers than that. Okay, so that's that one. Questions with this one? Does 4 make it work? 4 squared is 16 times 3 is 48. Negative 24 times 4 is going to give me 4 times 4 is 20, or 4 times 4 is 16. 1 is 84, or 80, yeah, 84. Subtract the 2, and we probably will get our negative 48 with this one. So we're good to go there too. Okay, so what about this thing? Way back, way back in chapter 6, when we ran across something like this, what did we say about it? X squared plus 4 equals 0. What can we do with it? Can we do anything with it? Perfect squares on each end, so it makes you think, oh, I can just write x minus 2 and x plus 2, but that's going to give me a middle, or a negative 4 on the end. When we were in chapter 6, we said that this was unfactorable because I can't come up with factors that give me this. But in here, because we have those lovely imaginary numbers now from chapter 9, we could take a look at this and we could say, oh, yeah, we can factor it. So now we're going to use that square root rule, and the square root rule says I'm going to minus 4 from each side. So it's a little different than what we did before. And now if I take the square root of each side, what will I end up with? Well, the square root of x squared is x. The square root of a negative 4, back from chapter 9, what's that going to end up being if I take the square root of a negative 4? 2i. 2i, imaginary. Okay, so if we took a look at this, and let's just do this to see what happens with my calculator if I graph this thing. So pull out your calculator, and we're going to put this equation into our y equals. So go to your y equals, and let's see what this graph looks like and see what happens to it. And we're going to do this from time to time of going with our calculators and seeing what goes. So if I put x, and I square it, and I add 4, and I hit graph, the reason we couldn't factor these before is because look what it comes out looking like. It's up there kind of hanging. It still graphs. It still gives me a parabola. But what happens with it is it never crosses the x-axis. So anytime I have imaginary numbers, I don't have any x-intercepts. So my graph is up here floating in the middle of my graph. And so it doesn't cross. So in this case, when we, of course, graphed this, it was up here, and it did one of these numbers. And where was it at? It's probably right up here at the 4 that I had in here. And so that's another piece that we will find later on in chapter 10 that's going to show us stuff about that graph and about what takes place with it. So when you get an imaginary numbers, there are no x-intercepts. So we don't have those. So they are not part of what we have when we do that one. So they're not there. Okay. So we flip the page here, and if we take another look with the square root property, we had things that looked like this back in chapter 9. Remember those? We had to solve and come up with what x would be. And so when we had this, again, same property, same thing. I think it was, what, 9.5 was where this was. So if we take the square root of both sides, what's going to happen? Well, if I take the square root of the side on the left, what will I get? On this side, I'm going to get a y plus 4. This side, I need to take care of 8. But when I take the square root, I'm going to put a plus and a minus because the value that can come out of that 8 could be a positive value or it could be a negative value. So we have 2 routes with these. One is, of course, the positive route and the other one is a negative route. So what does 8 break down to? Well, 8, the square root of 8 is equal to the square root of 2 cubed. And from chapter 9, we pulled out a 2 and we left a 2. So this is equal to 2, the square root of 2. So when we do that, that's the piece that we, of course, end up with. So far, so good? Again, skills from chapter 9. So chapter 9 is going to be playing a big role in all of this. So then, if I minus 4, I find out y is equal to a negative 4 plus or minus 2, the square root of 2. So on this parabola, it's crossing at 2 points, like some of the original ones, but it's not a solid straight number that you're going to get. It's a kind of a decimal number. We could calculate out what it would be by taking the square root of 8 and taking negative 4 and adding it to it. So the 2 answers that come out of this are a negative 4 plus 2 the square root of 2, or y equals negative 4 minus 2 the square root of 2. So that becomes our pieces, okay? So that becomes the part that's connected with this. So you've got 2 routes to it, okay? These 2 are where that parabola crosses the x-axis at. So it's these 2 points that we found in here when we do that, okay? Can I check that one? Pretty difficult to do because you'd have to figure out to calculate out your decimal answer for y, plug it back in, and square it, and then see if it equaled 8. And it should come out pretty close to what 8 would be, because if you've rounded or leave it completely in there as it is and add 4 to it and then see what you have, or then square that, you should come up with 8 for your answer to that one. Okay with that, you think? Okay, so let's look at this guy. This one is like that other one that we had. So if we go in and we take the square root of each side, I'm going to rewrite it just because then I have the original statement there without a square root connected to it. Square root of x squared is x. Whenever you do this, whenever you take the square root of the side, it's always going to be a plus or minus. And what I pull out of here, what do I pull out of that part? If I have a negative 25, 5i, perfect. Yeah, 5i. So it's imaginary. It would be floating as well down at a negative 25. So you would find if you did your parabola with this one, it would be way down on the y-axis and upside down more than likely because it will not cross it and show you where, or be up at a positive 25, sorry, because we're going to move it across. So it would be up at 25. So if you put this on your calculator, you wouldn't even see where it's at. And to put it on your calculator, you would have to move this back over and get set equal to 0 to do that, okay? Then it kind of moves right straight from that one into completing the square. And completing the square is a process that you can use to solve these. Again, is it the best method to solve it? It's when I cannot factor something and I need to come up with what its solution happens to be. Well, in this problem, over here, there's a plus something. If I make it a perfect square, so to make it a perfect square, you're going to take half of the middle term and square it to get the final term. So if I take half a 10, what would I place here to make this thing a perfect square? So half a 10 is 5. Take the 5 and square it, and I get 25. So to force this thing to be a perfect square, I would need to fill this hole in with a 25. If I set it equal to 0 and you factor this, what would it factor to? Well, it factored to x and x. 25 is a perfect square of 5 and 5. Since it's a plus 10, they're both pluses. Okay? So that's what it would force it to be. So again, we're not looking at this and saying, I know what that end number is in this case. It's just the step to get you to completing squares. So how would I find it? Take half of the middle and square it to get my end. And you can do that basically in your head. You don't have to write it on paper. Because half of 10 is 5, 5 squared is 25, and you know that ending is going to be 25 in there. And as we go through these, you'll see how that ties in with what we've got going with completing the square. So what about this one? Well, it's not quite as easy to take half of a -7, is it? So what you would do with this is you'll put 7 over 2, because still I want to find what this happens to be. So I have a -7/2. So then if I take a -7/2 and square it, what will I end up with? So that means a -7/2 times a -7/2, and I end up with -7 times a -7 is what? 49. And 2 times 2 is 4. So really on the end, that is what I have, 49/4. Okay? So 49/4 is what forces this thing to become a perfect square when I work with it. And so that's kind of the piece. Now, how do I get that 7 back in the middle? So if I factored this, it would be x minus 7/2 times x minus 7/2. So how does 7 come back? So x times x is, of course, x squared if I FOIL. X times x is x squared. X times that is a -7/2 x. Another -7 times that is another 7/2. -7 times a -7, or -7/2 times a -7/2 is that plus 49/2. But when you take these two and add them together, you get a -14/2. So 2 goes into a -14 7 times, so that's where that -7 comes back. So it works if you FOIL it back. So it hasn't changed my number in any way. It's just making it work and making it come up with what it happens to be for those. Okay? Oh, it should be a 4. Thank you. Yep, no, it should be because it's 7 times 7 and 2 times 2. Yep, that was my mistake. It should be a 4 down there. Yep. Okay, so we're working with this center. We're taking half of what it is. So whatever it is kind of taking it and dividing it by 2. And that's what we did back here when we had the solid, when we had the solid 10. Pull this one back. We had the solid 10, we still put 10 over 2, but the fact here is it reduced. 5 or 2 went into 10 5 times. Where here, I can't put 2 into 7, so it does not reduce. Okay? So this process is what we're doing. Do we need another one of those? Or do you think you're okay? What do you guys think? One more like that? No? Okay. All right. So that's what ends up taking place with those. So the completing the square method is using that. We're going to use it to take care of these. But it says to solve the quadratic equation by completing the square. And again, you will know if you have to use this because these things do not factor. You cannot make them factor. Back in chapter 6, we just wrote next to them not factorable, and we left them alone. We said we can't do anything with them. We're just going to leave them that way. See, when you get a little bit farther in math, then you got to take care of all those things you could never do before. So we're going to take care of that and make sure we can do it. So it says, if necessary, divide or multiply both sides of the equation so that the leading coefficient, the coefficient of x squared, is 1. So we're going to divide things out. We're going to make sure they're only equal to 1. So that means dividing everything in there by whatever is in front of the x squared. So if I had 3x squared plus 6x minus 8 equals 0, in order to complete the square, I would have to divide every piece in here by 3, okay? Every piece, including the 8. So in order to get this thing to work. So I'm going to end up with 8/3 in here, so don't be alarmed if you get fractions, because they do pop up in here, okay? So they are part of what does take place. So if necessary, isolate the constant term on one side of the equation. So sometimes we need to, or we're going to need to do that. So we're going to need to take this 8 and move it to the other side and get it so that we have that blank hole in there that's going to make us complete the square like we just did. And again, it'll make more sense as we go through that. Step 3, find the constant that completes the square of the polynomial and add this constant to both sides. Rewrite the polynomial in a square. This is where you take half of the middle. Well, that didn't come out right. And it'll make more sense as we go through it. Then use the square root property to find the solutions of the equation. So then I'm going to take the square root of each side, and we will end up coming up with what our solution is going to be. So let's take a look at this one. X squared minus 8x equals 25. So in the previous stuff, we could put 25 back over to the other side and have x squared minus 8x minus 25 equals 0. Can I have any factors of 25 that are going to add to give me a negative 8 in the middle? No way. 25 is only 25 and 1 and 5 and 5, and neither of those end up adding to 8. Okay? So we're going to leave this 25 on this side. So we're going to leave it sit there. And we're going to take this x squared minus 8x, and we're going to leave a blank there, and we're going to say, what would cause this side to be a perfect square? So if I take that negative 8, divide it by 2, I get a negative 4. Then down below, whatever that half is, you're going to set a binomial there that we're going to square. And we're going to say, okay, if I square it, it's going to come back to what I had up above. So now if I square negative 4, what's a negative 4 squared? 16. So if I add 16 here, I add 16 there. Remember in algebra, we always balance everything. Whatever you do to one side, you always do to the other. That's kind of that balancing act in there and making sure our weighted scales end up equaling each other. So 25 plus 16. So what's 25 plus 16? What was it? Okay. 41. Okay. We good there? Now I apply my square root rule. So first, recapping what we did here, we took half of the middle, wrote it down here, but only put an x in front of it and wrote it right there, took it, squared it, added it to both sides to get the new number on the right-hand side. So now if I take the square root of this side and the square root of that side, what happens? This side I end up with x minus 4. This side, can I do anything with 41? Can I pull anything out of it? Nope. It's a perfect, or actually it's a prime number, so there isn't anything I can multiply to get it. So I can only leave this as that. I cannot leave it in any other way. It has to stay as this, okay? So then if I add 4 to both sides, I will find out that x is equal to 4 plus or minus the square root of 41. And that is my x-intercepts. There are 2, because it's x plus, or 4 plus, the square root of 41 is equal to x, and x equals 4 minus the square root of 41. Okay, so you can see how chapter 9 is coming in here. It's being a part of what we've got going on. Okay, so far so good. So recapping what we did, we left the 25 over here. We didn't put it on the other side. We left a space for what it would make this side to be a completed square. So I took half of a negative 8, which is a negative 4, wrote that with the x down here, took the negative 4, squared it, added it to both sides. Then used the square root property, took the square root of both sides, and finally worked it down where I solved for x, and I got x is equal to 4 plus or minus the square root of 41. Because once again, the thing that comes out of here could be positive or it could be negative. Okay, so far so good? Okay, let's do another one. So in this one, is my x squared single? Not single, is it? It's got this 3 in front of here. So in order to work with these, I need to take every piece, divide each thing by 3, the 0 included. So these will cancel. 6 and 3 gives me a 2x. Negative 15 and 3 is a negative 5. And it's still equal to 0. Okay? So can I factor it? When you do that, see if it can be factored. Can I do anything with that thing? Too bad we weren't back in chapter 6 and we could just write not factorable and move on, you know. But we're not. We got to figure out what we got to do with these things. So we're not there. So now what I need to do is I need to get this first piece, the x squared and the 2x, all by itself. And I want to add 5 to both sides. So I get x squared plus 2x equals 5. Leave your blank hole in there, okay? So leave your blank hole so you don't have, so that you know you can fill that piece in. So half of 2, what's half of 2? 1. So I have x plus 1 down here squared. What's 1 squared? 1. And add it to both sides. So now I have a 6 on the opposite side. Take the square root of each side, and I get x plus 1 equals plus or minus, and I can't do anything with 6. If it were 12, I could have pulled out a 2, but I can't do anything with it, so it just stays. And I subtract 1, and I find out that x is equal to a negative 1 plus or minus the square root of 6. Okay? So that ends up being my piece to that. So I have 2 answers. So my 2 answers are x equals a negative 1 plus the square root of 6, and x equals a negative 1 minus the square root of 6. Okay? So that becomes my piece to this. All right? Yes? No? Okay. Now let's look at one that's not going to be quite as easy as the other one. This one, it has a 2 in front of x squared. So in order to work with it, I need to remove the 2 in front of there. All right? And again, this is just one method. When we get to the quadratic, and again, in this section, you need to practice this so that you know how to do the completing the square. But when we get to 10.2, we're going to use the quadratic equation, and that's going to make a difference in solving these two. So these cancel, gives me x squared. These 2's cancel, gives me an x. This negative 7 divided by 2, I can't divide it by 2, so I just need to leave it. Then I'm going to add 7 halves to both sides, because to complete the square, you need to have the first 2 terms by themselves. Okay? So what's in front of the x? Well, there's a 1 there. So what's half of 1? 1/2. Okay? So then if I take 1/2 and I square it, what happens? So if I square 1/2, so 1/2 times 1/2 is going to equal 1/4. And I'm going to add that to both sides. So again, these fractional pieces aren't probably always as easy to do as some of the other simpler ones. So you want to make sure you go through and get those. Can I just put 7 halves and 1/4 together? Nope. So I need 7 halves plus 1/4. So I need a common denominator of 4. 2 goes into 4 twice. 2 times 7 is 14. 4 goes into 4 once, gives me 1. So really down here I have 15/4. We good? Yes? No? Hopefully? Again, fractions are always the thing. I think they come through everywhere. I don't think it's the good firm foundation with fractions takes a while to get that built. And these have fractions in them. They show up every once in a while. So now I need to take the square root of both sides. So the square root of X plus 1/2 squared, the square root of it is x plus 1/2. What about this side? Again, chapter 9. Does 15 have a perfect square? Yes or no? Does 15 have a perfect square? Nope. So I have a plus or minus the square root of 15, but 4 does. What's the square root of 4? 2. So now I just move my 1/2 over, and I find that my answer is x equals 1/2, negative 1/2, because I changed my sign on it, plus or minus the square root of 15 over 2. So the two routes, negative 1/2 plus the square root of 15 over 2, or negative 1/2 minus the square root of 15 over 2. Okay? So just be careful when you got stuff that's not perfect halves in the middle. No. This one? No, because I took the square root of 4. No, I took the square root of 4, so no, it's supposed to be over 2, because 4 is a perfect square, so you can pull out a 2. Okay, so that becomes that part. Okay, we okay with that, do you think? Okay, let's do another one that's in here. Let's see what happens to this guy. See if you can solve this one. This one doesn't give you any fractions in the center. It just, that would help if you could see it, wouldn't it? I kind of pushed it up there a little bit with that last problem. So it does kind of help to be able to see what's going on there. Okay. Remember, the first two have to be by themselves, so 13 needs to go to the other side. Then you can finish it from there. This n number that goes in here is always going to be positive, not ever going to be negative, because you're taking and squaring a negative. So if you square a negative, you get a positive. If you square a positive, of course you get a positive. So it's never going to be negative right here. So keep that in mind. That's not going to ever be negative. So what's x going to be? Anybody get the answer? So x will equal what? So what number should go right here? If I take half of my middle, I have x, half of a negative 2 is what? Negative 1. Negative 1 squared is 1, and add 1. So you should have a negative 12 on that side. Square root rule. Square root of a negative 12 is a plus or minus 2 2i, the square root of 3, because it's negative, and we can pull out a 4 out of here, which means a 2 goes out in front. And then finally, add 1. And so x would equal 1 plus 2i, the square root of 3. And x would also equal 1 minus 2i, the square root of 3. So this is one of those hanging parabolas. It's not crossing x because it's got an imaginary part in it. So it's not crossing x at all, and it's not touching it. So there are 2 imaginary solutions to it. As soon as you put that I in, they become imaginary, and so it's not showing up at any location. If you put that on your graph, and again, I don't think it's going to show up because of the 13, we'd have to adjust our windows, so I'm not going to stick it on there. But if you saw that, it would be hanging. It wouldn't touch anywhere within that. Okay? What do you think? All right. We need to do another one. What do you think? Maybe one more with a fraction in it, if we can do one of those. So let's look at, there are examples in here. Let's take this example 4 and let's work that one out so we can see what takes place with it. So try example 4. It's got the dividing out of 2. It has fractional pieces in it so that you know what you're doing with those. Those are the trickier pieces that come out of these. So let's see what we can do with this one. Let me get another sheet of paper here, and I'll write it on that so we can see what happens with it. Hopefully, you're able to get it to, whoops, move it up there a little bit to that location. I don't know whether you made it there or not. Because square root of 49 is 7, and the square root of 16 is 4. We've got perfect squares there. So it comes out to be an actual answer, not a square rooted answer. So sometimes they work out that way. Sometimes you got a square root left in them. Other ones come out exact. So this is an exact of 3 and exact of 1/2. Because what you would have found is if we would have looked at this to factor it, this piece here, if we would have factored it and we weren't completing the square, we would have ended up with 2x plus 1 and, oh, wait a minute, I got factored correctly. 2x negative 3, yes, and x minus 3. So it would have factored, and if you would have set both of those two pieces equal to 0, you would have ended up finding our two answers were at the bottom. So it could be a method for factoring. I mean, if you reversed it and came up with what it would be. Okay, so you think you're okay? You think you can attempt these and try them and see what happens? Again, don't hop right into certify with this one, okay? You want to practice this stuff. So it's not just the certification piece in there. So there's practice problems in here. There's a type we did not do, so I crossed 6 off because we didn't end up reversing those. And so here's what they look like worked out. And again, I'm going to leave these on the tape so that if you're watching this, you can stop it and do your practice, and then you would end up having the conclusion of how they end up being worked out. Number 2 is another fractional one where you got to divide by 3. I think we did this one though in the assignment, or in the examples, and so forth. And then here's 4 worked out, and that's one we just did. So notice it was factored down here so that we can end up seeing it that way too. And then finally number 5. And number 5 is the final one that's in there. Number 5 has got a lot of fractions to it too. When you get through with this one, you're going to have the 3/2 on the other side. You can write it with a common denominator of 2 underneath it, and that's what we get when we do quadratic equations and work with those. Okay, so that's that piece. And then here's just the practice problem answers with that part. Okay, let's take a break, 5-minute break, and then we'll go and take a look at the quadratic formula and see how it works. let's get 10-2 out of the way. And so 10-2, I think you're going to probably like a little better than 10-1. 10-2, we can use this formula throughout the whole rest of the chapter to end up working on our stuff. So in your previous algebra lives, you may have run across this, and you need to know it. So each time you do a problem, make sure you write it down. You might have it sitting there and looking at it as you go through, but make sure you write your process down and write down what you do with it. So that's our quadratic formula. If you notice out front, there is a minus b. That minus has to be there. It is not connected with b. When you replace, and that's what we're going to work with this, when we replace letters in here with your b's, your a's, or your c's, you are still going to have that subtraction sign or minus sign or negative sign out in front of this b. So it's going to change some signs for you. So remember, that's part of the formula. So a negative b plus or minus the square root of b squared minus 4ac all over 2a. If you look in YouTube, there's all kinds of catchy little jingles that people have made for this. In my online class, I do have one that's posted in there that goes along with this. It's kind of corny, but it has a way of getting you to remember what you have going on with that. So we're going to develop the formula. We won't spend a whole lot of time on doing that because we're going to spend time on working with it. We're going to use the quadratic formula. We're going to take a look and calculate the discriminant. The discriminant is this piece that's underneath the radical in there. Just as we found in 10-1 and A and B, this has a lot to do with what's going to happen with this. If this came out to be an I under here, we knew we had two imaginary points on that parabola. If it came out to be a solid number, we ended up with two routes to it. And if this comes out to be 0 under here, the square root of 0 is, of course, 0. And there won't be any piece. So then we'll only end up with one answer. And that's where the parabola crosses only on one axis. So, again, it's going to tell me whether I have one real, two reals, or two non-reals. Non-reals are going to be the ones that have the I involved. So you're going to end up finding out that those are the ones that don't end up showing up or don't cross the x-axis. So you got an I piece that's in there. So you want to watch those. Okay, continuing. A note about the A coefficient, it says, for convenience without loss of generality, in the development of the quadratic formula and the examples and exercise, the leading coefficient A is positive. If A is negative number, we can multiply both sides of the equation by a -1, and this will make the leading coefficient positive without changing the solution of the original equation. Do we have to necessarily do that always? No, as long as you make certain that you are careful with putting in your negative. If you put a negative in the bottom when you multiply by the A that's in our formula, the one that's right here, you will end up finding out that you'll have to change your signs when you're all done. Okay? If the denominator came out negative, we would have to change this. So if you don't remember to change them to positives, it still works. It's not going to change your answer in any way. So where do we get A's, B's, and C's? Well, we get them when we get our quadratic formula in standard form, or in a standard situation where everything is to the left, 0 is on the right, and the A is always with your x squared, the B is always with x, and the C is always your constant term. So then you end up just putting those parts into your equation and end up solving it. The trickiest piece is, of course, under the radical, and we'll work with these as we go through those. So that's that piece. So let's see if we can solve this one. Now, if we were back in completing the square, of course, we remove the 3 over, take half of 5, we get all those lovely fractions, right? Okay, so we necessarily don't want to have all those fractions. So the very first thing you're going to want to do, and don't just rely on the fact of looking at this and plugging in your numbers. Always go through and assign A what A is, B what B happens to be, and C what C happens to be. Don't just say, I'm just going to look at it and I'm going to plug them in. The most mistakes that end up being made is not putting the right number in the right spot in the quadratic equation. Now remember, it will solve it. You'll come up with an answer, but it won't be the right one. So take this little extra step. It doesn't take you that long to identify A, to identify B, to identify C, and then go from there to see what happens. Okay, so let's put it in there. So we got to remember what our formula is. So x equals a negative b plus or minus the square root of b squared minus 4ac all over 2a. So as you start plugging your stuff in, notice this is a negative 5. I really have a negative times a negative 5 plus or minus the square root of a negative 5 squared minus 4 times 1 times 3 all over 2 times 1. Now you might look at that and say, oh gosh, it's gonna be difficult to come up with what I need to do with this thing. The most difficult part is this piece right here. That's the discriminant. So if you take this and you can stick that on your calculator, or a lot of these you can do just basically by hand, because if I square a negative 5, what do I get? I get 25. Negative 4 times 1 is a negative 4 times 3 is a minus 12. So I get 13 left under there. So my final answer is a negative times a negative 5 is a positive 5. 13 was what came out of inside of here, and in the bottom 2 times 1 is 2, and that's my final answer. So to get two pieces with this one, I have x is equal to 5 plus the square root of 13 over 2, and also x equals 5 minus the square root of 13 over 2. So easier? Usually a whole lot easier. It's like, okay, that makes it a little bit better to end up working with those. So you take these pieces, plug them in, come up with what your solution is going to be. Once again, it's 2 routes here, okay? And 2 directions with that. So what about this one? Our formula again is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And again, you need to know that. I'm not going to stick it anywhere, so you will not have it when you work with these. So identify my pieces. So what's A? A is 7. B, negative 2. C is 1. Okay, and plug them in. So I have minus a negative 2 plus or minus the square root of a negative 2 squared minus 4 times 7 times 1 all over 2 times 7. If we do the discriminant that's underneath, I get 4. Negative 4 times 7 is negative 28 plus times 1 is still a negative 28. 4 minus 28 is a negative 24. And if I take the square root of a negative 24 from chapter 9, what can I pull out of it? I can pull out a 2. I can pull out a 2. It's going to leave underneath and an I, and underneath the radical is going to be a 6. And in the bottom, I have 14. Whoops, 14. Not 144. The thing with this one, though, if you type that into Hawks and say, here's my answer, I'm good to go, it's going to come back and it's going to say it's not simplified. It's not simplified because notice there's a 2 here, there's a 2 here, and 14 also has a 2 in it. So this is really 2 over 14 plus or minus 2i, the square root of 6 over 14. So it can reduce. 2 and 14 reduce to 1/7. 2i and 14 reduce to just simply I, the square root of 6 over 7. So your true answer is x equals 1 plus or minus I, the square root of 6, all over 7. So sometimes you need to reduce them. Or you can do a triple reduce. If you've got this equation, it's the only time you get to triple reduce because this denominator would be under each of these, like I showed you. But you could say a 2 goes in here, a 2 goes into 14, and a 2 goes into here. But it has to go into all three. If this were a 2 and this had a 3, I could not reduce it. Okay? Leave it in this format. So be careful in watching what pieces you have in there to reduce those. So this would be what I would type into Hawks. So sometimes they ask you for separate pieces. So we know we would have 1 plus I, the square root of 6 over 7, and we would have 1 minus I, the square root of 6 over 7. So this parabola doesn't touch. So if I look at my discriminant under here, notice it came out negative. So this is what's considered a non-real number. So it's non-real. So it's not going to tell me, it's going to show me or tell me that it doesn't cross the x-axis at all. So it's non-real with what I have with that. Okay, so let's do another one. This one's got fractions in it. But as we said at the very beginning, we need to get rid of fractions. So how do we get rid of them? Well, I just simply find their common denominator. So what's my common denominator in this case? 12. And I'm going to take every piece of it and multiply it by 12. So 3/4 times 12, the 4 and the 12 will cancel. 3 times 3 is 9, x squared. 2 goes into 12, 6. 6 times a negative 1 is a negative 6x. 3 goes into 12, 4, and 4 times 1 is 4. Okay, so you want to get rid of fractions. Don't try putting fractions into your quadratic formula. It gets to be a genuine mess. Okay, so remove them. But it's not in my standard form, so I need to minus 4 from both sides. Now it's in standard form. So now I can find A is 9, B is a negative 6, and C is a negative 4. So once you get it to standard form, you're good to go. So if I write it down again, x equals a negative b plus or minus the square root of b squared minus 4ac all over 2a. Plug in 9 for a, negative 6 for b, and negative 4 for c. So I have a negative times a negative 6 plus or minus the square root of a negative 6 squared minus 4 times 9 times a negative 4 all over 2 times 9. This one's got pretty big numbers underneath that radical, so instead of trying to do it in my head, we'll use a calculator. So negative 6 squared is 36 minus 4 times 9 times a negative 4. And I find underneath my radical is good old 4. So now I have 6 plus or minus the square root of 4 all over 18. Square root of 4 is 2. So I will get 2 solid straight answers. I don't need to leave anything in the radical part to this. Oh, I didn't do that part right. Somehow I have a minus 4 in there. Whoops. 4 is not under there. Let me redo that one. So 36 minus 4 times 9 times a negative 4. There. Now we'll get what's underneath it. 180 is under here. I was going to say I didn't think it came out to be a nice simple one under there. So 180 is under there. And so what could I pull out of 180? I can pull out, and breaking 180 down, I can pull out a 6 and it's going to leave a 5 underneath. And then these can be reduced. So if you did the triple reducing, 6, 18, and 6, I would end up with 1 plus or minus the square root of 5 all over 3 for that one. So it helps if you stick it on your calculator right and don't come up with what I ended up coming up with. So be careful with getting that discriminant done correctly. So this one has, because it's a whole number of 5 under here, it has 2 real solutions to it. And so it would be considered real. So that's what my discriminant's telling me about that one. Okay, what do you think? Yes? No? Okay. And make sure that when you cancel, you don't just cancel the 2 piece in here, because that won't end up being correct. It ends up being wrong because I can't just cancel 1 piece. If you were going to cancel this one, the thing you would have to do is break it apart and cancel the pieces that you could cancel. Factor out a 2 out of the whole piece on top, then cancel your 2. So be real careful with your cancellations when you do quadratics. Finding the discriminant, you only use the piece because our formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. The only piece I use for the discriminant is what's under the radical. That is the determining factor of what types of pieces and what types of things we will end up with. So be aware of that it's only that piece that we're looking at. So that's why in here they only used the discriminant piece and plugged in your numbers. B was 11, 4, minus 4, A was 3, and C was a negative 7, and came up with 205, which is greater than 0, and therefore there's 2 real solutions. So if it's greater than 0, that's what we end up with for that discriminant and coming up with what it would be. So what happens with this one? What will I get for my discriminant in here? What types of things are going to happen? So I need A is 1, B is 6, and C is 9. So I'm only taking that piece underneath that radical. So B squared is 6 squared minus 4 times 1 times 9. 6 squared is 36. 4 times 1 is 4 times 9 is 36 equals 0. So what this would mean is I would only have 1 solution. So then if you finish this one, you would have a negative 6 plus or minus the square root of 0 all over 2 times 1, or 2. So the only piece that I would have when I'm all done with it is just that x would equal a negative 3. So my parabola is coming down here, touching at 3 and heading up. And that's all it has. So this has 1 solution. And I could tell that just by the discriminant of where it's going to cross and what's going to take place with it. So it has 1 solution. And then the last one here, what would I end up with? Well, if you have no, it's in standard form, but what do you notice? I have no what? There's no B. There's no single X in there. So A is 1, B is 0, C is 1. So if I do my discriminant, I have 0 squared minus 4 times 1 times 1. So I end up with a negative 4 is what's left in there, which is a non-real. Because remember, it's always the square root of it, so it's non-real. So therefore, I know that's going to be an imaginary one if I worked it out. Okay? So these are the keys. And then this is just kind of giving you the idea of determining what happens to determine 2 reals or 1 answer or 2 non-reals or imaginary numbers. In this case, there will be 2 reals if this value is greater than 0. There will be only one answer if it's equal to 0, and there will be two imaginary numbers if it's less than 0. So this piece, if you want to stick that in your notes, that's the important piece of that whole thing. So I'll give you some time to write that piece down and come up with what that would be. But that's the part that comes in there, and that's the part we work with. So. Pardon? On the bottom, right here? Oh, up here? Determines two real answers, one real answer, or two non-real answers. But that's good to have, because then even when you're doing just a regular problem, you can end up practicing this whole thing with discriminants, because whatever comes underneath that radical is going to tell you whether you have two answers, one answer, or no, or two unreal answers, or non-real answers that you could work with. Okay. Sure you all got caught up on writing. Did you get that off of there? Okay. All right. And so then so then we need to find the roots on using the, whoops, do I need it back? Oh, I'm sorry. Sorry. Yeah, no, I can put it back. I thought you had it, but that's okay. It can go back. That's the only bad part with this stuff, is you don't have sometimes enough time to write all of the pieces down. These are the sheets that I use for this are the ones that come out of the PowerPoints that Hawks has. They're ones that are posted in your Canvas course area, and you just look up those sections, and that tells you the different pieces to it. This piece is not in there, but I felt it was pretty important that you end up having that part to pull this whole thing together of what one's what. Okay now? Okay. All right, so let's just determine some discriminants with these so we can figure out what in the world we have happening within these. So again, find your A's, find your B, find your C, and only do your piece up there. So 2 squared minus 4 times 1 times 1. And so I get 4. Negative 4 times 1 is a negative 4. So I get 0. So this one has one answer. So only one answer. Okay. The bottom, this one over here, A equals a negative 9. Whoops, first off, that's not set up right. Notice these are on the other side of the equal, so I need to move them over first. Change their signs, move them to the opposite side. Then you can find A, B, and C, and then plug them in. So I have 12 squared minus 4 times a negative 9 times a negative 4. Well, 12 squared is 144. But the other part, you probably want to use your calculator for. And I get a negative 324. And I'm going to 144 minus that is going to give me a negative 180. And so I know I have two imaginaries with this one, or two non-reals. And then C, the very last one, what do you get for C? Is it 2 reals, 1 answer, or 2 non-reals? So you should have 2 non-reals out of that one because it came out to be a -7. Okay. Questions with discriminants? Again, write that formula over and over and over so that you get the habit of knowing what it is. It's not really too hard to remember once you work on what happens to be with that. So that's what happens with those. Okay. So then we are to practice problems, and again, quadratic formula, you use that in order to solve these. One with fractions is this one. So you would want to make sure that you multiply by your common denominator of 4 to get rid of your denominators in there. And then everything should be good from there with those. So the practice problems worked out. I'll put them up here. And again, stop the video if you are watching that, and so you can get what those happen to be, or stop the page that has the practice stuff, and then you can get your problems off there and work them out, and then see if you have worked them out correctly. So then here's the other ones. Signs become an important part, so you want to make sure. Number 4, once we got all the fractions out of there and worked it all the way through, it came up with just one solid answer of 1. Discriminants again, square root of 81 in 3. That's going to tell me I have 2 answers when I work with this. So those discriminants are in, of course, every problem that you work with. And so then here's number 5. And number 5 did not have a B, and it comes out imaginary in the tail end with some cancellations. And notice there's no 0 out in front, so it's all based on the second piece to that one when you work those out. So there's the answers, and again, we didn't do 6, so that's the ones with those. Okay, so that is the end of that lesson. Let me get this taken care of.